What's going on YouTube? This is Ipsec, and we're going to be doing a vulnerability assessment on HELK, and hopefully showing you how to do security on vendor web applications that you don't have a lot of control over. We do this by implementing a reverse proxy to send all the requests through, and that reverse proxy puts things through ModSecurity and SSL Mutual Authentication to make sure they're not malicious and they're coming from an authorized source. Anyways, I think HELK is a really great candidate for this type of assessment because it's a weekend project built for testing and validating techniques to facilitate learning in a lab environment, hence why it is still in an alpha state. But the application itself works so well, I bet people still decide to pilot it, and we all know pilot means production in lieu of testing, so let's do some security testing to give them guidelines on how to use this application safely. But before we get into the fun stuff, I do want to explain my methodology of a vulnerability assessment, or at least how I approach them, because that will sum up everything that we cover in this video. The first step is to justify or limit what services are exposed, and we do that by running NMAP and Nessus to identify all the ports we can see, then review the documentation to identify what each port does, and close the ports that we don't need to be opened. And then the next step is to place a firewall in the middle of communication to prevent unexpected data from traversing the network. This doesn't have to be a network firewall. We're going to be using ModSecurity, which is an application firewall specialized for web servers, and that will help us prevent any type of cross-site scripting, SQL, command injections, template injections, shell shock, etc. from reaching our server. So in the case of a 0-day, hopefully we are protected against it. Then the next step is segmenting access to those that need it, and the basic philosophy here is saying, if there's a server out there in the forest that is vulnerable, but there's no one there to exploit it, are we even going to consider it vulnerable? A good example would be ILOs, the lights out management that provide remote physical access to servers. If the only people that talk to those are admins, then why would an admin even bother exploiting the ILO because he has admin over the server anyways? Why even have that ILO be presented to users and give them that attack surface? So we're going to be segmenting access through SSL Mutual Authentication, and essentially that means the servers won't talk to a user unless the user has a special certificate that says who they are. And finally, we have keep software up to date, which many people believe to be the most important thing to securing a network, and I just don't. I'm not saying don't update your stuff because you certainly should. I'm just saying if the only thing that stands in the way between you and getting popped is your ability to patch before the bad guys read blog post on Twitter, Reddit, or ExploitDB, you're going to have a bad time. You have to have other measures in place to stay ahead of that whole one-day exploit wave, or whatever it is called, or just pen testers in general. So with all that being said, let's get into the fun stuff and perform a vulnerability assessment on HELK. The first thing we want to start out with is viewing what ports are exposed to us, and we're going to do that by running both Nessus and NMAP. We're going to do Nessus first because it takes longer, so once we kick it off, we can let it work in the background. Right now, I am SSHing into the HELK box to make sure my credentials are good. They are. So the username is Ipsec and the password is please subscribe. So I can go over to Nessus, log in, and create a new scan. Let's do an advanced scan. The name of the scan is going to be HELK. The IP is 172.16.10.10. We're going to do a discovery, port scanning. 1 to 65,535 is all ports. Go to credentials, SSH. Password, username is Ipsec, and we want to put the password as please subscribe. I gotta type this twice, so I'm just putting it here. And then, boom, we'll elevate with sudo. Username is Ipsec, password is please subscribe. That looks good. Let's go to plugins. All plugins are enabled, so let's launch this scan. So while that launches, let us do a manual nmap of the box to see what is exposed. So nmap-p- 172.16.10.10. This is going to check for all available ports, and we see quite a few are open. So I'm going to create another pane, and we'll make notes-ports, and start off. We have 22, which is SSH. This is needed for administration. If we're doing a securing Linux box video, we probably just enforce public key authentication only and get rid of password logins and do things like fail to ban and things like that. 80 and 443, these are going to be web services and needed for Kibana / searching logs. 5044, this is unknown. It's not unknown. We can just go up here, do a docker ps ~S, permission denied, sudo double bang, put the password, please subscribe, and that will run the last command I had done. So we can see port 5044. Where is that? This is tied to Logstash. If we go over to the HELK design, Logstash is here. It only talks to Kafka, and the servers that we need to talk to are these. So since these go through Kafka and not to Logstash directly, we can probably safely close off this port. So let's go down. This is Logstash, unknown purpose, probably safe to close. 8088, that is Kafka KSQL server, and KSQL is sitting here. So I'm guessing that's the one that's open and only talks to Kafka. So that is KSQL, probably safe to close. And then 8531. Let's go. I don't see that anywhere. I have no idea what 8531 is. So let's close that. Netstat ALNP. Nets.not found. SS-LTP. And let's see. 8531. It's not telling me what process is using it. LPTN, no. SS-H, grep PID, -IPID. Let's get rid of the T for TCP and just do LPN. Do we have PIDs here? grep PID. Okay, we do have PIDs. So what was that port we wanted? 8531. 8531. grep PID. Sudo bang bang. I should just sudo su. That is docker-proxy. And let's do less-s. Users docker proxy, PID 1837. So PSEF grep 1837. And that is container 172.18.05. So sudo docker ps ~S 1805. Who are you? 172 does not tell me the IPs. It does not. There's a docker command for that. It's we'll just do sudo docker inspect and then loop that with sudo docker ps aq. And then we can search for 1805 and then search now for name. And we get Logstash is that port. And was I just blind? Let's do sudo docker ps ~S. And Logstash is here. And 8531 is indeed a Logstash port. So let's do Logstash, unknown, prob safe to close. So the last port we have is 9092. And from my winlog beat config, I know that's where we send logs. So we send logs, and that is not Elasticsearch, Kafka. So it's very important to do things like this because one of these services I know is relatively unsafe to expose. So let's close out of that and clean up a terminal bit. We'll see if Nessus has finished to see if Nessus tells us anything. It is done, so let's look at this report. And we only see 2 mediums, 1 low, and the rest informational. So we see the mediums are probably going to be these SSL issues, which are probably safe to ignore. The other ones, nothing of true interest. We have it detecting Nginx. Let's check the authentication. It was successful on authentication. Let's do ports. Port scanner. It should see all the same ports we did. Doesn't really identify them too much. Let's look at... I don't know what else to look at. So we'll just go back. Oh, we can search for KSQL, because that's the one we're going to manually look at. Searching for that, we have nothing. So what is KSQL? Well, let's see what we can do with it. If we go to the HELK GitHub page, and it is worth mentioning that HELK is an alpha product, not meant for production, and it's made by Cyber War Dog on his weekend time, so not officially supported, and of course, alpha state, so dragons are buried, I guess they would say. Let's go to the wiki. Where is the wiki? Here it is. And he should have information on Kafka. Here it is, down below. And he has instructions on installing the KSQL command line client locally. So let us follow this. So go to the Confluent platform, download it, email, we'll do ipsec@abc.com. Probably doesn't have to be a valid email. Download, and we can save the file. It looks like the download is finished. So let's go back to our box and just move that file here. So move downloads, what was the file name? Confluent to our local directory, and then untar it. And then let's go into the directory and see if we can find where the KSQL bin is. So it's in just bin, and then KSQL and HTTP 172.16.10.10, port 8088, and see if we connect. It takes probably about 5 to 10 seconds to connect. And once it's connected, we can do show topics, and this is kind of like show tables. So we can do a print winlog beat from beginning and start dumping information out of the messaging queue. So we can see this is certainly not our data. So this came in at 1309, and it is from winlog beat. This is technique name credential dumping. So something talked to LSAS here. But if we go here and enable our Windows box, resume guest, we should see this start streaming. The box is online now. So let's see. There we go. There comes another message. There's another one, a registry event, another one. So we can just start intercepting all the logs going to this topic. So that probably shouldn't be exposed to the network. And that's what we will work on closing now. So always important to dig into things. And not that Nessus isn't a great tool. I do love it and use it quite often. But you can't just expect it to find anything, or Freudian slip there, I guess. Find everything, I should have said. Because, well, KSQL is a new technology, etc., etc. And yeah, so let's move on and start blocking ports. So the first step is to find what our interface name is, so we can specify that. If config's not on the system, so I use IP-ADDR. And then we look at the interface that has the IP 172.16.10.10, and it is ENS33. So my first step is to do a sudo iptables-a input to append a rule on the input table. And we're going to specify -i ENS33 -p TCP -d port 8088-j drop. And then we go back and let's verify we are dropping the packet or port. So specify port 8088 on 172.16.10.10. And we can see the port is still open. So let's do a sudo iptables-L and look at our input table. We can see it clearly says drop, but Docker obeys the one in this docker-user chain, so we have to add it there. So let's remove this one rule. So we'll change that capital A to a D. And then we want to do an I instead of an A. So we insert a rule at the top because we don't want to put it below the return. So I is top, A is bottom. So docker-user and leave the same thing. I did a underscore, or I think underscore, yeah. So now we did that rule. We do an NMAP, and it's now saying filtered. And I don't like this for like internal ports. So it does slow down NMAP scans, but it still shows like a firewall is in place. So let's delete that rule. Go back to I. Instead of a dropped, we're going to do reject. And let's do this NMAP again on port 8088. Still says filtered. So we need to delete this reject. And we want to do -- reject with tcp-reset. Because if we didn't do this, let's just copy this and look at what rule it is and see if we can see what it says. The best way I found to get verbose information is just do sudo iptables -save. And we can look. Let's see, where is the drop? I don't see any rule. Oh, we deleted it. So we'll go back to that reject rule. And we see it's rejecting with ICMP port unreachable, which Nessus says that is filtered. So let's put our reject with tcp-reset and do an NMAP scan, and it says it is closed. So if we just do a flat out NMAP on 172.16.10.10, that port no longer shows up. We have other ports we want to close, so let's also close 5044, 8531, and I think that was it. So let's do a nmap -p 172.16.10.10 and see what comes back. So we have 8531. Did I typo that? I did typo that. I am known for the typos. That's why we always verify our work, especially when it comes to securing things. So we do the nmap again and see we have 22 going to a justification that is needed for administration, 80 and 443 that's needed for Kibana, and 9092, this is Kafka, how we're getting logs into our system, so everything is good. The next step of this video is the firewall portion, so we're going to go over to draw.il to quickly draw a basic architecture diagram, and then we'll start configuring everything. So let's create a new diagram, blank is fine, and this is going to be stupid simple. So let's do workstation, and we'll put ourselves here. This is going to be clients. I might make this a bit bigger. And we can put a web server. Website maybe is a better one. Sure. We'll put this here. This will be website or HELK. So how we are connecting is just going straight to it. Now, we won't always have control over this web server, for instance, if it is an ILO device. So one thing I really like doing is creating reverse proxies internally. So we'll just put server here, and we'll call this the Rev Proxy. And this is just going to run Apache 2 ModSecurity, and that will help prevent against things like cross-site scripting, command and template injection, shell shock, etc. So, and it also allows us to do SSL Mutual Authentication. And then our client talks to this, which then forwards out the request over to the HELK server, and our client doesn't even know he's even going to this Rev Proxy. But this guy sits in the middle and makes sure all the web data that goes to HELK is good. And then once we have this up, we can configure the HELK firewall to only allow 80 and 443 traffic from the Rev proxy. So I have created another box, and it's just running Ubuntu right now, and that is 172.16.10.15. So let's go and SSH to them. And it's just a most up-to-date version of Ubuntu. So I'm going to switch to the root user because we have a lot to do. And then we begin by installing Apache. So we'll do apt install Apache 2 and let this install. We could use Nginx, but I find the ModSecurity installation on Nginx to be a bit painful, and it becomes a bit hard to install updates because the Nginx mod is compiled from source. So yeah, that's why we're using Apache. Config's a bit more difficult to set up with Apache, but at least it won't break every time we update. So with Apache installed, let's set up the Rev proxy. So go to etc Apache 2, and then we want sites-available, and we can cat default ssl.conf. Let's grep-v on all these comments, grep period, and then send this to helk.conf. And we can delete the default ssl.conf and go to HELK and start modifying this. So virtual host, this is the IP address we want to listen to or listen on, and then we can have a server name variable, which would then mean if it sees that host header that has HELK in it, it goes down this virtual host. So that's how that works, and that would allow this Rev proxy to host multiple sites. So the important configurations, let's remove the ones we don't need. We don't need server admin. We don't need document root. Logging is good. SSL engine we need. Don't need these. And we need to put a proxy request off, proxy preserve host on, proxy pass everything to HTTPS 172.16.10.10, proxy pass reverse on HTTPS 172.16.10.10. And I think that is what we need. We need actually SSL proxy engine on, and we need to probably enable mod SSL proxy and things. So A2 EN mod SSL, and we want A2 EN mod proxy and proxy HTTPS, proxy HTTP. Okay, so we did those three modules, proxy, proxy HTTP, and SSL. So we can do systemctl restart Apache 2 and go to a Firefox browser 172.16.10.15, and it goes to the Ubuntu page. Oh, we want to go to HTTPS. Secure connection failed. Received a connect that received maximum length. Let's go tail var log Apache error log var log Apache other host, and it doesn't look like we did an HTTPS request. I'm guessing it didn't send a HTTPS request to Kibana. So let's cat this config out again. And wait, sites enabled. And there's the error. We never actually enabled our site, so what's listening on port 443 isn't configured to. So let's just enable the site, helk.conf. And it wants us to reload the configuration. So we'll do that. And all that enable site command does is creates a symlink and sites enabled that points to the configuration and sites available. So if we refresh the page now, we should get that SSL certificate. And if we accept it, we get another error message. So let's look at the Apache log and see if we can figure out what we need to do. So Apache 2, error.log. And let's see. Server certificate does not include ID which matches server name. That's a warning, so maybe fine. Error. Pass request to body failed. And it just dies. So what I'm going to do is enable the debug log. So let's go to log level. Whoops. And change it from 1 to debug. And I'm going to clear out the Apache log. I'll do that once we restart. So reload Apache, wipe the Apache log, then refresh the page, and we will cat the log. And we get a lot of information. So let's grep for error. And let's see. Body failed, SSL handshake, and that's exactly what we expected, or what we saw before. So if we tail it, let's see. We see it grabbing the certificate of HELK. Peer certificate does not match host name, and then it closed. So maybe this is what we want, this info. So I'm going to go back into our SSL config, and we're going to do a bunch of things that are, I guess, maybe bad. So we'll do SSL proxy verify none, SSL proxy check PeerCN off, SSL proxy check peer name off. I think these two are the same thing. I think peer name is the newer one of CN. And then we'll also do SSL proxy check peer expire off. So now we're just accepting any certificate it gives us. So let's reload the config, refresh the page, and we get a login prompt, which is good. So HELK and hunting. What? DNS lookup failed for 172.16.10.10 app. I'm guessing that is going to be a configuration. Proxy pass. We need to put slashes on the end of the IPs. Reload. And there we go. So now our reverse proxy is configured. The one thing we want to do is take Apache out of debug mode so we don't fill our logs. So put that back in 1. Reload. And we should now be able to begin installing ModSecurity. So I'm just going to go over the Discover tab real quick to make sure we get some type of logs to make sure this is working. So user regression test, I guess. Last 12 hours on sysmon, we see data. So I think it's safe to say Kibana is working. So let's go back to our root and we'll begin installing ModSecurity, which should just be in apt. So we'll do apt search mod-security. Maybe no dash. Let's do apt edit sources. We'll do 2 for Vim basic, and I think it's in the Universe package. So we'll enable Universe, and this is like maybe, I don't know what a good way to describe this is. Not officially supported, but probably stable. So maybe that's the best way. So do apt update. And we probably should do an apt upgrade afterwards, but I'm lazy and it should be fine since all we did was enable Universe. So we'll do apt search ModSecurity. And there we go. We have the package. So we'll do apt install lib apache 2 -mod security 2. Install that. And we see from this script, it's already enabling the module, setting up ModSecurity-CRS, which is the core rule set, which is amazing. So the core rule set is more of a level based. So just one bad thing may not flag it as malicious. It does multiple levels and multiple checks and identifies if it's bad. That way, if like something's coming from Amazon AWS, you don't assume it's malicious right away, but you add like 5 points to it. And then when it has dirty words like select, exec, etc., then you add another point to it. And let's say we drop everything at 7 points, and the dirty words give it 3 points. The AWS gives it 5. You're above 7, which drops the packet. And if you just came from what looks like a residential IP, chances are it may not be malicious and doesn't get that extra 5 points tacked on because it came from Amazon. And now it thinks it's a good request and passes it. So you can do a lot of really cool things with ModSecurity and core rule set. So let's go to Etsy. ModSecurity, and we want to just move ModSecurity recommended to modsecurity.conf. We can look at modsecurity.conf and see what it is. It's in detection only, and if we go into our Apache config, we can actually override this to say we're on and actually block. But in this mode, it won't ever drop pages. It'll just alert you. So let's, I guess, reload Apache, which it probably did. And we can probably go to var log Apache 2. And then we got modsec audit.log. So we'll look at this, go back to a reverse proxy, and we'll put / ipsec is equal to /bin/bash. And if we look at this, we see a bunch of things that may have flagged that. Oh my God, there is so much here. It's flagging probably on something Kibana related. So this is request 920 protocol enforcement. Host header is a numeric IP address. Okay, that one's probably fine. We can ignore that. Let's see. There is a lot more work than I thought there would be here, maybe. Let's just turn it on blocking mode and see if we can get it working. So let us go to Etsy, Apache 2, sites enabled, HELK.conf, and we will turn ModSecurity on. So we will add sec rule engine on and restart Apache. And then when we go to ipsec equals bin bash, we get a forbidden, which is good. If we go to just Kibana, it looks like the page is loading. Go to discover, and we get authorization exceptions here. So let us go back to ModSecurity and look at the modsec audit log. So score exceeded, total inbound score is 8. Doesn't see SQL injections, cross-site scripting request, forgery, RCE, PHP, whatever. So let's see. Content is not allowed by policy tag, event correlation. Let's see. This is probably, nope, that's msearch. Let's see. What is this flagging? That's authentication, pattern match. Let's just grep message. So grep message, modsec audit log, grep-i message, -a-i. So let's do less-S. Go to the bottom and see what we have. A lot of protocol enforcement. Tag application, IP host. So maybe if we just went to this page as a domain name, it may not block. So let's try that. So in our Kali box, v etc host, we're going to say 1010, oh not 1010, 172.16.10.15 is going to be www.helk.local, we'll say. So here we can do www.helk.local, and we have to do HTTPS, advanced, add exception, confirm, HELK, hunting, go to discover, and we still get authorization issues. So let's go back to SSH and look if we have anything else. So I'm going to clear this log. We will refresh the page and see what it said. Refresh the page and see what it says. So on discover, come on, get that error message. There we go. So let's see. Where is our thing? Request content type is not allowed by policy. So content type, what content type are we? Encoding, application multi. There it is. Application / x-ndjson. So let us search our logs for content type and enable that. So let's go to etc ModSecurity, CRS. That's not where the rules are. Where are the rules? Let's do an update DB to update our file system. Now we can do locate modsec. And our rules look like they're in user share mod security. So user share mod security rules, and we can grep for content dash type on everything. Looks like it's in request 920 protocol enforcement. Look for content type. Restrict which content types we accept. Going here, we get a variable allowed request content underscore type. So let's grep content underscore type on everything. And it looks like on request 901 initialization, we have a set var. It is right here. I just don't want to click to erase my clipboard. So request 901, search for content underscore type. That's not it. Here we go. Looks like we just put a pipe for and then paste application x-ndjson. So now we can reload Apache and we can refresh this page and see if ModSecurity is now working or now no longer blocking us. So we don't get that authorization thing, which is good. If we go back 12 hours, we are good. And let's verify that everything's working by doing like ipsec is equal to /bin/bash. And we get error messages there. So I think everything's good. So let's do $ipsec equals /bin/bash. Yep. So ModSecurity definitely is working, but it doesn't look like it's blocking legitimate requests, which is good. So let's just double check to be positive, because nothing's worse than implementing a WAF in blocking mode and then having it block a VIP's request. So, yep, there we go. So everything looks good. If you see error messages when you're doing searches, chances are it may be ModSecurity blocking your search. If we search for like bin/bash, no error message popped up, so it doesn't look like ModSecurity blocked it. But let's move in to the final part of this video, which is going to be the mutual authentication to make sure that only authorized people actually talk to this Kibana instance. To do that, we're going to go back to our local box and create a certificate authority. So I'm just making the directory CA, but if you were to do this, you may want to put this on like an encrypted PGP drive or USB drive, because these files should be considered extremely sensitive and not really stored in a place where they could ever be compromised. Because if someone compromises your CA, it becomes a huge pain to rebuild. And they can do a lot of things like man the middle all traffic and just destroy SSL in general. So what we're going to do is create a notes file real quick to explain everything. So the first thing we have is the CA's private key, and this is kept offline, used to sign stuff. That doesn't have to be kept on any server whatsoever. Then we have the certificate authority public key, and that is going to be kept everywhere. Everyone needs this. This has like the trust hierarchy and everything. So after we have those two, we have the website private key and the website public key. And this is kept on the website. And the website public key is distributed to users. And then we have the user private key, and this is stored in the web browser. And the user public key will be what is sent. And these two things, if I can do this in any comprehensible way, get stored in a PFX file. So I think that explains it. Hopefully I explained it correctly. I'm not an expert on SSL, so it's my understanding of it. So the first thing we have to do is generate that certificate authority. So we'll do OpenSSL, gen RSA, the encryption, which will be AES-256, out, ca.key, 4096, and enter a passphrase for the key. Let's enter it again. I can't type. There we go. We have created the certificate private key. So now we have to create the public cert. So we'll do OpenSSL request new x509 days. This will be good for 1 year. The key, this will be the private key, and -out will be the certificate. Enter the password for the private key, and now we got to create something. So we'll do US New York, organization name, awesome cyber guides, unit name, IPsec, and the CN for this will be internal CA. Email address is nothing. So now we have two things. We have the public key and the private key for a CA. So now we have to generate stuff for a website. So we'll do OpenSSL, gen RSA, AES-256. Oh no, OpenSSL request, new key, RSA 2048, nodes key out. And this will be HELK.key -out, HELK.CSR. And we'll do US, New York, was it awesome cyber guides? Is that what I said before? Yep. Organizational unit will be IPsec, and the common name will be www.helk.local. No email address, and we won't worry about a password here. So next thing we have to do is sign this key. So we'll do OpenSSL request, no, x509 request days 365 HELK.CSR. And when we did this file, if I said that was the public key, I was wrong. That's certificate signing request. I'm kind of just on autopilot. -ca, ca.cert, -ca key, ca.key, set serial 01-out. This will be HELK. I thought I typed in. It should be in there. And this will be HELK.key, I think. Or no. CRT. This is the public cert. So this is the website's public key. I think that's all good. Unrecognized flag, CA key. Maybe it's a lowercase? There we go. Enter the password for it. And now that key is signed. So we have to do that same process, but for a user certificate. So we'll set the serial to 2, and we'll do in. No, we need, here we go. This one. IPsec. So we do OpenSSL request new key, RSA, nodes key out, IPsec.key, and then out IPsec.certificate signing request to create our stuff. So we do US, New York, organizational name, awesome, cyber guides, IPsec, common name, IPsec. And we won't worry about a password. And we have to sign it. So we do OpenSSL x509 request days 365. The in file is IPsec.certificate signing request. CA is the CA. Set the serial to 2. And we'll output IPsec.crt. So now we have everything signed. So what we want to do is copy the correct keys to a HELK server or the reverse proxy. So we'll do SCP HELK stir to IPsec at 172.16.10.15. Put our password in, and I typoed that. Okay, we have copied all the HELK stuff. So we go back to our SSH, go to etc Apache 2, look at where our SSL certs are stored, so sites available, HELK.conf, and we're in the SSL cert snake oil stuff. So etc SSL, and then we'll copy the CRT file into certs, and then the private key into private. So copy IPsec HELK.crt into certs, and then HELK.key into private. And the last thing we have to do is edit the config. So HELK.conf, rename these keys to be HELK.crt and HELK.key. And we also have to do the SSL CA file. So SSL certificate, SSL CA certificate file. CA certificate file is equal to etc SSL certs CA, or we called it like internal CA.crt. So we just have to copy that last one. So let's go back to a bash window and scp ca.crt to IPsec. So please subscribe. Go back. cp IPsec ca.crt into etc SSL certs internal ca.crt. I think that's what we called it. Internal CA.crt. Reload. And when we refresh this, we get a SSL warning. If we go to add an exception and we view this, we can see this is indeed the certificate authority. So if we trusted this CA to identify websites for us, we won't get this error. So I won't click through this. If I refresh, we still get that. So let's add our CA. So go into Preferences of Firefox, Certificates, and then let's do Authorities, Import, and we want to go into root, and it's under HELK, CA, ca.crt. Trust it to identify websites. And if we refresh this page, we no longer get a certificate error. So our CA does work. The only thing we have to do now is configure Apache to require client certificates. So let's go back into helk.conf. And then at the very bottom, we can just put SSL Verify Client Require. So we'll reload, refresh the page, and we get an SSL warning because the server cannot verify who we are. If we go into varlog Apache 2, it should tell us we have issues. We'll do tail-f. Maybe it will, maybe it won't. Nothing in error. Tail access. Doesn't look like it. Tail other. Nope. I don't think it's telling us. So we probably have to play with logging to get that. Yep, does not. But as you can see, we can't view it until we go into our certificates, go into your certificates, import, and then, we have to do the PFX creation. And that's what we forgot to do. So go back to our box, and we have to create that PFX file. So we will do OpenSSL pkcs12-export out ipsec.pfx nkey ipsec.key, and then -n we'll do ipsec.crt, and I think that is good. Export password, we'll leave it blank, and we got a PFX now. So let us go back to Firefox, import that, and you probably should put passwords on these things. I'm just not, because you see how often I typo passwords, and for the video's sake, I didn't feel like doing that. So now when we click try again, we get a prompt saying the site requested us to send it our certificate, and we're sending it our user certificate saying IPSEC, and now we can authenticate to Kibana. So we now have the mutual authentication done. The only issue we have left now is our Kibana instance is still listening on 172.16.10.10. So we just have to remove this access, and then we will consider our Kibana secured. So let us go back into the actual Kibana server, which is here. And we are on root at HELK. So let us do iptables -L, and we're going to add reject rules and accept rules. So we'll do iptables -I, and then docker-o history grep iptables. I don't know where that went, so we'll have to just retype the drops. So we do iptables -I docker user -I ens33 p tcp dport 80-j drop, and we do 443 as well. So now if we go back and try to access Kibana on 10.10, we can no longer do that. So the downside is right now a reverse proxy can no longer do that as well. So we're going to do -i ens33. We want to do drops with TCP resets. We won't worry about it. You saw that early in the video. So instead of drop, we want accept. And instead of port 443, we do -s 172.16.10.15. And if we now refresh this, Kibana is working, but the Kibana here is not working. And if we go down and NMAP on 172.16.10.10, we will get only port 22 is open. And remember, these are filtered because we didn't reject it with the TCP reset. We just decided to drop it. So the last thing I guess we do is have iptable save. So when we reboot the box, our iptables aren't just reverted. So we'll just do apt install iptables persistent and start installing this package. Save current v4 and then v6. I forgot about v6. So this would be a fun one if you haven't watched a lot of my videos. There's actually probably a way around everything we just did because IPv6 link local. So as long as you're on the same subnet as the server, you may be able to bypass it. So let's do IPADDR, look at ENS33, and we see this FE80 address. So let's confirm down here by Nmap. We cannot access it. Everything is filtered. So let us do nmap-6, put the IPv6 link local, and then because it's a link local, we have to do % the interface we want to scan from, which is ETH0. And when we scan this, everything is open. And that is because the rules we changed were only for v4, not v6. So v6 is still left open and everything was listening on it, which means we have a little bit more work to do before we can consider this box secured. So I'd rather just completely disable IPv6 because I don't think anything's using it. So let us begin by, we got to edit the sysctl stuff. So that is etc sysctl.conf. Let's just go to the very bottom and do net.ipv6.conf all disable IPv6 equals 1. And then we'll do net.ipv6.conf.default disable IPv6 equals 1. And then we got to edit grub. So etc default grub. And we have to do the cmd line Linux to also have IPv6.disable equals 1 and grub cmd line IPv6.disable equals 1. It is a pain to disable IPv6. And then finally, we have to rebuild grub with update-grub. And once this is done, we can reboot the box and make sure everything comes back. So rebooting, and I will resume the video once this comes back. So pausing it now. The box should be back online, so let's SSH to it. Do please subscribe sudo su. And if we do iptables-l, we can see everything is still there. If we do IPADDR, we can see ENS33 does not have any IPv6 stuff. So it looks like everything was successful. If we do a nmap on that IPv6 address, it is offline. And if we do nmap 172.16.10.10, we should only get 22 is open, 80 and 443 are filtered, the rest we blocked the correct way. And if we go into a reverse proxy, let's see what happens. We are loading Kibana, so everything looks great. We should have 90, 92 or something open, and that may just be because I didn't do -p-, because without that, we're not going to be getting logs into Kibana. So everything looks good. I think we can call it a day saying we did a good job securing this application. Yeah, take care, and I will see you all next week.